Hey y'all, and good morning. Well, it's the morning for me at least. Anyways, here are your finding key features in graph and quadratics notes. What I want you to do right now is go ahead and pause the note video and do this first review section at the top, and then you can unpause and see if you got your key features down correctly. So go ahead and pause it now. Alright, so if you're coming back with me, check out your answer, see how you did. This is a quadratic function. It is negative. Remember we say if it makes a sad face, then it's negative. Therefore, it has a maximum point, also known as our vertex, which is at 7, 1. Our axis of symmetry cuts through here at x equals 7. Make sure that you do have that listed as x equals 7 and not just 7. And our roots, or where it crosses the x-axis, is at 6, 0 and 8, 0. Alright, so today we're going to learn about how to find these things on our own without the graph. Instead, they're just going to give us the equation. So here we go, finding our axis of symmetry. You do get this formula on your star chart. It is x equals opposite b or negative b over 2a. Let's go ahead and write down our standard form over here too for our quadratic functions, ax squared plus bx plus c. Alright, so that way you remember who is a, who is b, and who is c. So given that information, we can now label our parts and find our axis of symmetry. So what value is here for our a? That's a 1. So I have a, b, and c, and then from there we just have to plug it in to our handy dandy formula. Alright, so I'll have x equals negative b, so negative of 8 over 2 times a. So that would be negative 8 over 2, which is negative 4. So our axis of symmetry here would be at x equals negative 4. Alright, one other note I wanted to make on here too is that this is the x value of the vertex. Remember, because if I look up here on this example, the axis of symmetry will always cut through our vertex points. They will share the same x value every time. And if you want to make a note of what it is that we're looking at here, this is our axis of symmetry. Alright, so y'all go ahead and look at this next problem. Now, the problem with this one is that it's not in standard form yet. So you have to first put it into standard form in order to correctly label your A, B, and C, and then you can find your axis of symmetry. So go ahead and pause the note video, put it in a standard form, and try to find your find your axis of symmetry on your own. Alright, so if you're coming back with me, hopefully you rearranged your equation back into the correct order. It was y equals 2x squared minus 7x minus 4. So I could label my a, b, and c, and then plug it into my formula. Now you have to be careful here, because remember our formula says negative b over 2a. Well, my b value is already negative 7, so I have the negative of negative 7 over 2 times a. Remember, this is a double negative, so it'll become a positive 7 over 4. Now let's say you were going to go and graph this thing and you're like, I don't know where 7/4 is. Well, you could just type it into your calculator, and now we know it's between 1 and 2 on our x-axis, and then we could draw it in from there. Shimmying down here to find the vertex. Alright, we got a couple steps to write down here. Our first step is going to be to find your axis of symmetry. Alright, and the reason why is because, like we mentioned earlier, is that this represents the x value of your vertex. Our second step will be to plug in x value that we found. And then our third step is going to be solve for y. And remember that our vertex point will always be some x, y coordinate. Right? And if we want to kind of draw what we're looking at here, our vertex is this point right here. Right? And that's what we're finding in this section. Alright, so same thing, we want to go ahead and label. This is A, B, and C. So my first step is going to be to find my axis of symmetry using my formula. X equals negative B over 2 times A. That's going to be negative 6 divided by 2, which is negative 3. So now I know that my x value is equal to negative 3. Once you have found your x value, we're going to plug it into our equation. So I'm going to have y equals 1x squared. And now I know that my x value is negative 3 plus 6 times x. Again, this is the x value we got, and plus 2. Good news is if you're careful and you're using your parentheses, you can plug this whole piece into your calculator at one time. All right, we get negative 3 squared plus 6 times negative 3 plus 2. And we get negative 7, or we get y equals negative 7. Alright, so now I have my x value and my y value. My vertex for this problem is going to be at x is negative 3 and y is negative 7. Yay, not too bad. Alright, so let's talk about the second example before you try it on your own. Alright, what are we missing here? Well, hopefully you've recognized that we are missing our b term. If we don't have a b term there, it's probably definitely because it's a 0. Alright, so y'all will actually like this one. It's pretty easy, so I want you to try this one on your own. So go ahead and pause the note video and find your vertex. Alright, so if you're coming back on here with me, hopefully you got your vertex at the point 0, negative 7. Alright, so first I had to do x equals negative b over 2a. Well, there's no such thing as a positive or negative 0. It's just a neutral number, right? And then, so we ended up with 0 on top, 6 on the bottom. Now, if you're unsure about this point, because I know you get a little concerned when there's zeros happening, you can type it in your calculator. 0 divided by 6 is still 0. Now, I have a little note over here. So if I have 0 on the top, 0 is being divided by some number, that's okay. But it's not okay to have some number divided by 0. So for example, if this was 6 on top and 0 on bottom, 6 divided by 0, that's when you would have an undefined or a no solution. But 0 is our answer, so then I took it and I replaced it in here for my x value. So I had 3 times 0 squared, 0 times 0 is 0, 3 times 0 is 0, and I was just left over with this negative 7. So our vertex is at 0, negative 7. I asked my classes, I said, what else is this point representing? And it's also, oh, gosh. It's also representing the y-intercept, right? Because if I looked at a graph, it'd be over at 0, and then somewhere down here at negative 7. All right, let's go ahead and flip over to the back. All right, so this is where things are going to start to get really fun. Finding the rocks is, now remember the rocks, those stand for roots, zeros, x-intercepts, and solutions. So basically all that means is it's wherever our graph crosses the x-axis, and that's what we're going to be finding with this. All right, so here we go. This is always going to be some number for x when y is equal to 0. All right, so here's how we're going to have to do these. Be excited. We are going to factor and solve. Now the solving part means that we are going to set factors equal to 0, and then we'll solve for x. So all of those great memories you had of factoring before spring break are coming back here now. Now, if you're listening from a different class period, you're not in Miss Harper's class, you may have learned to factor a slightly different way. So kind of roll with the way that you know how to factor your problems, but we should end up at the same factor answers, if that makes sense. Okay, so I want you to factor in the way that you know how to factor, and then we'll still end up at the same answer here. All right, so for this first example, I'm going to go ahead and do my same thing here. Well, actually, so whenever I go to factor this thing, so I can't actually factor. So remember, you have some questions to ask yourself whenever you go to factor. First is this quadratic in standard form? Well, it's in the right order, but my leading term, my a value, is negative. And we've learned that a is not allowed to be negative. It can either equal 1 or be greater than 1. So I can't factor it just yet until I factor out that negative. So I'm going to do that in my first step by dividing out a 1. So I'm going to take out a negative or a negative 1. You can write that in if that makes you feel better. I'm going to divide everything by a negative 1 and see what I'd be left over with. And that would be a positive x squared, a positive 8x, and a positive 15. And now I'm just going to focus here on this part right here, and I'm going to factor it. So go ahead, this is how my class factors. We're looking for something that multiplies to 15 but adds to 8. So my factors of 15 are 1 and 15, or 3 and 5. So obviously it's going to be the 3 and the 5, and they're both going to be positive. Alright, so I have this, and it's going to become x and a positive 3, and x and a positive 5. We found our two missing puzzle pieces there. Alright, so after we have completed this step, alright, so remember that our x-intercepts are whenever y is equal to 0. So if I plugged in a 0 here for y, and I can now solve for x. This is kind of weird, and it's a step that I usually skip, but I wanted y'all to recognize I was plugging in 0 for y. So after we've done that, now I can take each of my two factors and set them both equal to 0 like this. X plus 3 equals 0, and x plus 5 equals 0. Now, why am I doing this 2 times? Well, we've seen on most of these quadratic functions already that most of the time they cross our x-axis in 2 different places. And then from here I solve for x. So I'd end up here with x equals negative 3. So that means it would be crossing at negative 3, 0. And this one, if I subtract 5, I end up with x equals negative 5, meaning that this guy is going to cross at negative 5, 0, and those would be my two x-intercepts here. So all along while you were learning to factor, we were secretly setting you up to take this one step further in order to find your x-intercepts for these quadratic functions. On this second problem, I want you to go ahead and try to factor this one. Now, this is the longer route one for my students. You're going to have to take this a couple steps further. Now, if you're in another class, you may have learned to factor in a different way. So I want you to pause the note video here, go ahead and factor this the way that you know how to factor, and give this example a try on your own. Alright, if you're coming back here with me, hopefully, again, our work could look totally different, but we did factor by grouping in my class, so this is how we did it. I found my two missing pieces, so I replaced them with a 1x and a negative 8x. I factored out my GCF, found that my two parentheses were matching, and so I could rewrite my two factors. I got x minus 4 and 2x plus 1. I set both of those factors equal to 0, and then I solved for their corresponding x values. At this point, I want to write these as coordinate points, so I can say that my x-intercepts are at the point 4, 0, and negative 1/2, 0. Yay! Alright, so now we're going to go ahead and try these next two examples on our own with everything, so all together now. I'm going to go ahead and do this first example with y'all, and then I'll let you try your second example on your own. Alright, so here we go. First I'm going to find my axis of symmetry. So I'm going to do that by using my formula, x equals negative b over 2a. 1 is my a value, b, and c. So I'm going to use x equals negative b over 2 times a. That is negative 12 over 2, which equals negative 6. So x equals negative 6 is my axis of symmetry. Alright, now let's go ahead and graph that in here. So 1, 2, 3, 4, 5, 6, negative 6, and it's always going to be a vertical line. And typically we use it as a dashed line for our axis of symmetry. Next, to find my the vertex, I know it's going to be somewhere at negative 6. Now I just need to find its y value here. So I'm going to do that by plugging in negative 6 for all of my x's. Plus 12, times negative 6 plus 35. All right, remember you can use this your handy dandy calculator to do this step. So that is negative 6 squared plus 12 times negative 6 plus 35. All right, and here we get negative 1 for our y value. So y equals negative 1, and then I can plug that here and go plot that point. So negative 6, negative 1. If your vertex is not sitting on your axis of symmetry, then you have made a mistake. All right, in my next step, I'm going to find my x-intercepts because we need 3 points to graph these things. So here comes my first 3 points. All right, so first thing I'm going to do is factor my quadratic function. It is in standard form. There is not a GCF, so I'm just going to go straight to finding out what my two factors are. I'm looking for something that multiplies to 35 but adds to 12. Factors of 35 are 1 times 35 or 5 times 7. 5 and 7 are going to be our guys, and they both get to be positive. So it's going to be x and a positive 5, x and a positive 7. Now I set those two factors equal to 0, and I solve for x. Now hopefully you're recognizing at this point it's just going to become the opposite value. So I'm going to get x equals a negative 5 and x equals a negative 7. Now we like to write those two things as coordinate points. So over here I'm going to put negative 5, 0 and negative 7, 0. And let's go ahead and plot those points too. So here's negative 5 and here's negative 7. Now remember that this is your axis of keyword symmetry, all right? It should be cutting right through the middle of your parabola. So if you ended up with one root over here and one root like over here, obviously that would not be symmetrical, all right? So good news is we are symmetrical here, so after that we can go ahead and graph our stuff. Now remember the a value here determines if this thing opens up or down. So we have a positive 1, and we can kind of tell by our points the vertex is our minimum. So we're going to make it a nice curvy U-shaped parabola here. All right, make sure that you make it a U and not a V. A V is a different type of function that you'll learn about in Algebra 2. All right, let's finish this problem up. Our domain is all real numbers. And our range, we have y, and then remember it's the y value of your vertex. Now do I have values that are greater than negative 1 or values less than? Remember if it opens up, we have values that are greater than or equal to negative 1, with negative 1 being our low point and anything greater than that. Now before you jump to the second example, I just want to make a quick note. So go ahead and do your axis of symmetry and your vertex first. So I want you to find your axis of symmetry and vertex. So pause the note video now and find these two pieces first. Alright, so hopefully you're able to find your axis of symmetry and vertex on your own. I went ahead and drew both of those things in. I got my vertex at negative 1, 8. I'm also going to make a quick note. Since my a value here is negative, I know that this thing is going to open down. So next thing we're going to find are the roots. Now I just wanted to make a quick note here that for your roots, there is a GCF that you have to take out first before you can factor this thing. So what is your GCF here? Well, the GCF here is negative. It's actually 2, but since our leading term is negative, we can't have our a value be negative when we factor. We have to factor out a negative 2. So then I'd be left over with this. All right, x squared plus 2x minus 3. All right, so go ahead and pause the note video here and factor this part and find your two roots. Alright, so if you're joining me again, hopefully you're able to find your two factors of x plus 3 and x minus 1. Set those equal to 0, solve for that x value, and we got x equals negative 3 and x equals positive 1. Now I did want to make a quick note. Some students were asking, well, what about this negative 2 out here? So kind of if I set negative 2 equal to 0 as one of my factors, is this a true statement? Well, no, it's not. So therefore, negative 2 is not an official, he's not a root, but he is a factor of this equation. Okay, so now and then I went ahead and plotted my 2 points over here, and again, look for that symmetry on either side of your axis of symmetry, and then we can draw in a nice curvy U shape, like that. Alrighty, our domain, as always, is going to always be all real numbers. And then for our range, it's y, and if I can't mark the lowest, but I can mark the highest, and that's here at 8, and I have values less than or equal to 8. So y is anything less than or equal to 8. And that is how you find algebraically all of these key features of quadratic functions. Go see your teacher in tutorials if you need extra help.